Now, this is one of the most important concepts in the whole discussion of vectors, and that's the scalar product of two vectors, also known as the dot product. So here's the thing. The scalar product is basically, first let's discuss what the concept really is. If you have two non-zero vectors, u and v, right, in the plane or in space, and they have the same initial point, which means that basically, let's say this is the vector u. Since this is the initial point of u, the second vector must start from this same exact initial point, right? So this is vector v. They have the same initial point. The dot product of u and v will be written like this, but how is it defined? So u dot v is equal to the magnitude of u multiplied with the magnitude of v into cos theta. What is theta? It's the angle, this angle, between the vectors u and v that we're taking the dot product of, right? And the theta must lie between pi and 0, or in terms of degrees, between 0 and 180 degrees, right? Now, and another reason why that is because if you have this as the vector v, again, this is v, and let's say that this is the vector u. Now, this is still an angle between them, but let's say this is vector v, and let's say this is vector u. You'll not take this as theta. No, that's not correct. This is theta, which is why theta must lie between pi and 0. Because once it exceeds this 180 degree mark, you'll take the short angle. So that's practically useless, right? It will always lie between 0 and pi. Now, the definition of perpendicular or orthogonal vectors. The two vectors u and v are orthogonal or perpendicular if and only if u dot v is equal to 0. How will it be 0? Remember that the dot product or the inner product or the scalar product, they all mean the same thing, by the way. They're the same, right? So I into I is equal to j into j is equal to k into k, which is equal to 1, which basically means anything on the x-axis being multiplied with anything on the x-axis again is basically in the same direction. So let's say this is the vector u, and the vector v lies on this same exact, is parallel to the vector u, right? So what is the angle between them? It's 0. And what that means is that it's basically the dot product of u and v is equal to u, the magnitude of u, into the magnitude of v, into cos of 0. And remember that the cos of 0 is equal to 1, right? But in this case, it says I into I, which means 1 on the x-axis and 1 on the x-axis. When they're taking the dot product, their magnitude is also the same. So that's basically equal to, in the case where both of them are equal, not this case really, in this case, 1i into 1i. So the same vector of 1 taking a dot product of 1 with itself is basically equal to 1, the magnitude of 1, 1 cos 0, which is equal to basically 1 into 1 into 1, which is equal to 1. And same goes for j into j, k into k, right? They're parallel vectors of one magnitude literally being multiplied with each other in the same direction. The I and I are in the x-axis, j and j are in the y-axis, k and k are in the z-axis. So they'll all give you the same result of 1, right? So we'll apply the same logic to perpendicular vectors. Remember that I into j, which basically means, let's just make a, whoops, forget the drawing, but right, let's just say this is a 3D plane, right? Say that this is the x-axis, this is the y-axis, and this is the z-axis. It says the I into j is equal to 0. Why is it equal to 0? Because let's just say this, we have a vector on this, let's call it, this is the vector I, and on j we have this vector j, right? They have an angle of 90 degrees between them, right? Because if you look at it from a bird's eye view, it looks like this, right? X, y, and this is the 90-degree angle. So the angle between I and j is 90 degree, and cos 90 is equal to 0, which means that any term being multiplied with this is equal to 0, in which case I dot j is equal to magnitude of I into magnitude of j into 0, which is equal to 0. Same goes for j and k, right? Because the y-axis and the z-axis are again at 90 degrees from each other. So let's just say this is k. So again, at 90 degrees, the cos term, cos 90, becomes 0. So this is also equal to 0. And the z-axis and the x-axis, or k and y, are also perpendicular to each other at 90 degrees. So that is also equal to 0. And that is the concept of orthogonal vectors. And the scalar product is commutative, right? So u dot v is equal to v dot u. We've discussed this earlier. Now, the properties of a dot product. We let u, v, and w be vectors, right? And let c be a real number or a scalar quantity, right? So u dot v is equal to 0 if the vector u is equal to 0 and the vector v is equal to, that's pretty self-explanatory, right? Because in this case, since u is equal to 0, it's a 0 vector. V is also equal to 0, it's a 0 vector. So obviously 0 into 0, it has no magnitude. This has no magnitude, right? Is equal to 0. And the magnitude of v is also equal to 0. So obviously 0 into cos of any number is always equal to 0, which is why we have the 0. Now, again, u dot v is equal to v dot u, the commutative property, simple. And we have the distributive property again, which says that v plus w, the vector, the sum of v and w, right? The result of the sum of the vectors v and w being multiplied then with the vector u is equal to, as if you basically multiply u and v, then you multiply u and w, and then, right, u and v, u and w, and then you add the results up, right? So this is the distributive property, basic math really. So now we are doing multiplying the vector u with the scalar c, and the result of this multiplication is then multiplied with v, right? This is equal to, as if you first multiply the vector u and the vector v, taking the dot product of u and v, and then multiplying the result of that dot product with the scalar c, right?